All right, this is going to be day 2 of related rates. I'm only going to do 2 problems, 4 and 5, since 1, 2, and 3 are kind of review in terms of geometry of your shadow problem and the cone problem. So 1, 2, and 3 are going to be geometry. Review those, but we're going to focus on 4 and 5 since these are going to be kind of special. So for number 4, we have an airplane that is at an altitude of 5 miles directly over a radar antenna. So we have our radar antenna and we have 5 miles right here. When the plane is 10 miles away, the radar detects the distance is changing at a rate of 240 miles per hour. We want to figure out the speed of the airplane. All right, so we have 10 miles away, which represents my Z. So here's my airplane. And then we have my horizontal distance. All right, so I know that X is something, Y is 5, Z is 10. Well, using good old Pythag, 10 squared minus 5 squared is going to give us root 75. So this is going to give us root 75 right here. Now we know that the radar detects the distance is changing at a rate of 240 miles per hour. So notice how this one right here, dz dt, is changing at a rate of 240 miles per hour. Because the airplane is changing from here to here, the speed changing, or the distance. And we're going to figure out the speed of the airplane. Okay, so in order to find the speed of the airplane, we want to find out what dxdt is, aka this right here. And the reason why is because I don't really care about this. Since it's an altitude of 5 miles away, it's always going to be 5 miles away here. So this is changing right here, but your height will always say 5. Which means since your height is always saying 5, dy dt is equal to 0. Thinking about your good old Pythag and your derivative here, I'm going to go ahead and skip a step and go to the shortcut where I have x dx dt is equal to z dz dt, because remember y squared dy dt is going to be 0, so that's going to cancel out. I know that x is root 75. I'm trying to figure out what dx dt is. Z is 10 and dz dt is 240. So then if I were to simplify all of that, I'm going to get dxdt being 10 times 240 over root 75. And then since we are looking at the speed of the airplane, this is going to be miles per hour. All right. Number 5. We have a camera that's pointed 3,000 feet from the base of a rocket launching pad. So we have a camera, 3,000 feet. The rocket is rising vertically at 880 feet per second when it is 4,000 feet above the launching pad. So we know that this is 4,000 feet. And we also know that dy dt is 880 feet per second. So 3,000, 4,000. Z is going to be 5,000 using your good old 345 Pythag triple. And it tells us how fast must the camera elevation angle change at that instant to keep the camera aimed at the rocket. So we're trying to figure out what theta is. All right. Let's see. Notice how your horizontal distance of 3,000 is never going to change. The only thing that's changing whenever we're talking about our elevation is going to be my hypotenuse and my height here. Since if I were to look at this, notice how it's going to change right here. So dz dt is going to change and dy dt is going to change, meaning that dx dt is going to be 0. Well, the thing is, I don't know what dz dt is, so whenever we are working with these types of problems, I'm not going to be using dz dt in terms of finding my equation. All right, so I need to figure out what my equation is based off of x and based off of y. So thinking about this, I have y right here, my opposite, and then x being my adjacent. So that's going to give me tangent. So I have tangent theta is equal to opposite over adjacent, so y over x. I'm going to go ahead and take the derivative with respect to time. So that's secant square theta d theta dt is equal to low d high minus high d low all over low square. Well, good news is we know that dxdt is 0. So since dxdt is 0, this part right here just cancels out, meaning that I'm just left with secant square theta d theta dt is equal to dy dt and then 1 over x, since I'm going to simplify that. All right, so remember that secant is the reciprocal of cosine. Since it's the reciprocal of cosine, what I'm going to do is think about, let's see. Cosine is adjacent over hypotenuse. So that's going to give me 1 over 3/5 or 5/3. So now I'm going to have secant square theta, so I'm going to square that. So instead of 5/3, I'm going to have 25 over 9 d theta dt is equal to dy dt, which is 880. And then I have 1 over x, which is 3,000. And then if I were to solve for d theta dt, I'm going to get 880 over 3,000 times 9 over 25. And that is going to be my answer. And hopefully, if I did this right, that's going to give me 0.105. So let me double check. Yep, 0.1056 to be exact. Of course, since this is angle, this is going to be radians per second. All right. So overall, with related rates, this is going to be the last video of related rates. Overall, make sure that you clearly label your x's, your y's, your z's, what you're given, and its derivatives. And then based off of that, see what you definitely know and see what you don't know. And then based off of that, make your equation based off of what you know. All right. The next section I think is going to be on NVT and Extrema. So that's going to be a lot of fun, I think. We'll see what happens. I'll see you in the next video.